Okay, so I'm going to continue with what we have started in the last video. Sometimes you're gonna get questions like this. Find the maximum value of x squared minus 4x plus 1 and graph the quadratic. So when we are asked to find maximum or minimum value of a quadratic, the form that gives us the max and min is this form, ax minus h squared plus k, the vertex form. And k is the max or the min, depends on a is positive or negative. So this is another way to say switch or put this in vertex form using the method of completing the square. I just asked the same question, but I rephrase it. I said something different. Okay? I said find the maximum value of this. Max and min, we need the vertex form. And how we go from standard form to vertex form, it is through the method we just learned in the previous video. It is called the method of completing the square. Again, the method of completing the square is a method that allows us, if we don't have a perfect square, to somehow complete that square and make it perfect so we can put it in the vertex form. What are the process? There was 5 steps. So what was the first step? The first step was group the first and second term. So we group those. Okay, this is the first step is done. Second step, get the number in front of x, which is b. So that's negative 4. Divided by 2, that's negative 2. Then square the value you get. So you get 4. Okay, this is the second step. Number in front of x divided by 2, square it. Then what we're gonna do with this, to make this a perfect square, we need to add this. So we're gonna add it. When we added, this is not the same as this because I added 4 to it. So it is not the same. How I overcome this problem? I subtract the 4. How this helped? Because that means I added 4 and subtracted 4, so I added 0. So I didn't change anything. I just played the game. Okay? Now, I just need this because this is the perfect square part, so I don't need the negative part. So I will take the negative value out. So now x squared plus 4x plus 4, and take the negative 4 out. Now, if we look at this, we have a perfect square. Oh, sorry, this is minus. We have a perfect square. So we just can factor this as a perfect square. So we can say square root of the first, sine of the middle, square root of the third, and we put a square here. Then we combine those. So negative 4 plus 1 is negative 3. Now this is in the form of ax minus h squared plus k. What is h? It is 2. What is k? It is negative 3. Is this has a max or min? It has a max. It has a min. Min because a is positive. A is positive. What is the maximum value? The maximum value is negative 3. The minimum value equal negative 3. Okay? So now we answer the first part. Now the second part, it says graph the curve. So I'm going to sketch a graph for this. The first thing, I will plot the vertex. So I have the vertex at the point 2 and negative 3. So this is 1, this is 2, this is negative 1, lowest point, then I know also that I have a y-intercept at 1 from the standard form, so y-intercept in here at 1. This is -3 and this is 2. Okay, I know that the axis of symmetry passes through the vertex. So if I have a point at 0, 1, I will have a point at 4, 1, because they must have the same distance because of the symmetry. Right? Now I can sketch the graph. Okay? Alright, so this is how we complete the square when A is 1, and this is how we graph, and this is how to find the max or min. And I still have time, I can give you another example. So, maximum or minimum, sorry, it was a minimum here. It was a minimum. When A is 1, it is always a minimum. Tomorrow we're going to do when A is not 1. I want to give you another example. So let's say y equal x squared plus 2x plus or minus 3. Let's make it plus 3. Okay? I want to find the minimum value and graph, and I want to graph this. So this is a quadratic in standard form. Minimum or maximum means I need to have the vertex form. This will have a minimum because A is positive. To switch from standard form to vertex form, I have to use the method of completing the square. This is not a perfect square, so I have to use the method of completing the square. What is the method? The first thing is we group the first and second term. We did. The second thing, we get the number in front of x, which is b. We divide it by 2, and then we square it. Now, we are going to make the perfect square, which is x squared plus 2x plus 1. Now, this is a perfect square, but I cannot do that. If I add, I have to subtract so I don't change the identity of the quadratic I have. Then I don't need the negative value, so I will take it out. So now it will become y equal x squared plus 2x plus 1. I'll take the negative 1 out. Then when I look here, I found that I have a perfect square because A is a perfect square, C is a perfect square. Square root of A times square root of C times 2 equal the middle term. So I can factor the perfect square. So x sine of the middle, square root of the third, combine like terms. So this is the, now we have the quadratic in the form of ax minus h squared plus k. What is the vertex? The vertex will be -1 and 2. Right? So is this a max or a min? This is a min equals 2. Okay? Now I want to sketch a graph for that, so I will do this. The first thing, I will plot the vertex, so -1 and +2. This is 2 and this is -1. It opens up. I know that I have a y-intercept at 3. And I know that I have an axis of symmetry passing through the vertex. So this is -1. So if I have a point at 0 and 3, because of symmetry, I will have a point this is today's lesson. Tomorrow we'll continue with this, but instead of having a equals 1, we're going to have different values, -2, -3, -1, any other value. It will be, we're going to add one more step only when we have this. So for now, I want you to practice this process when A equals 1. Your homework will be page 5 to page 7 in the package I'm going to post on SB. Okay, please send me your questions if you have any, and have a great day. Bye.